Today I will present the results of an econometric analysis examining how machine maintenance affects production output at loaner. The central research question of this analysis is whether increasing machine maintenance improves production output at loaner. Specifically, I aim to answer three questions. The first question is, does higher machine maintenance increase output? The second question is, by how much does output change when maintenance levels change? And third, is the relationship statistically meaningful, or could it simply be the results of random variation in the data? Before estimating any model, it is important to understand the data. The histograms show the distribution of output and machine maintenance rates. Output appears roughly normally distributed around its mean. Machine maintenance rates vary within a relatively small range. These descriptive statistics help us understand the scale of the variables and confirm that there are no extreme outliers that would distort the regression analysis. Next, I examine how output and maintenance change over time. The time series plots show that output fluctuates moderately across months, while maintenance rates also vary across time. Because these time effects could influence production independently of maintenance decisions, the regression model includes year-fixed effects to control for systematic change over time. The analysis assumes that production output is determined by several factors. These include machine maintenance intensity, worker characteristics such as education, age, and salary, and machine characteristics such as machine age and operating hours. In addition, time effects may influence production due to seasonal factors or economic conditions. The error term captures all other unobserved influences that affect output but are not directly measured in the dataset. Before estimating the final model, I tested whether the relationship between maintenance and output is linear or nonlinear. A quadratic specification, for example, was estimated to check for diminishing or increasing returns to maintenance. However, the squared maintenance term was not statistically significant and the model fit did not improve. Therefore, the linear specification was selected as the preferred functional form. The model estimation results for the linear specification is shown in this slide. The model is estimated using ordinary least squares regression. Ordinary least squares, or OLS, estimates the coefficients by minimizing the errors or square differences between predicted and observed output levels. To ensure reliable inference, heteroskedasticity-robust standard errors are used. The regression also includes year-fixed effects and several control variables representing worker and machine characteristics. The main regression results show that the estimated coefficient for machine maintenance is negative, with a value of approximately negative 10.45. This suggests that higher maintenance is associated with slightly lower output. However, the p-value for this observation is approximately 0.82, which means the effect is not statistically significant at the conventional 0.05 level, although it is marginally significant at the 10% level. Therefore, the evidence for maintenance effect is relatively weak. As a robustness check, the model was re-estimated including the variable faulty units. When this variable is included, the sign of the maintenance coefficient becomes positive and the magnitude changes substantially. This sign reversal suggests that faulty units may be endogenous or mechanically related to output. Because of this concern, the preferred model excludes faulty units from the regression. To interpret the regression results in practical terms, I compute predicted output changes for realistic maintenance adjustments. When maintenance is increased by 10% relative to its mean, the model predicts that output falls by approximately 0.24 units. Similarly, a 10% decrease in maintenance slightly increases predicted output. However, the magnitude of these effects is extremely small. Therefore, increasing maintenance is unlikely to generate meaningful productivity gains. Based on the estimation model, increasing machine maintenance does not appear to significantly increase production output. In fact, the estimated effect is slightly negative, though the statistical evidence is weak. Therefore, the analysis suggests that increasing maintenance alone is unlikely to generate meaningful productivity gains for learner. Um, in other words, management should not increase maintenance budgets to boost output. Instead, productivity improvements could be achieved from improving worker education and training, or some other factors such as optimizing production hours, upgrading aging equipment, and others. So basically, maintenance should be maintained at current levels to prevent breakdowns, but increasing it is unlikely to raise production. The point estimate represents the estimated marginal effect of maintenance on output. In this case, the coefficient indicates that a 1 unit increase in maintenance is associated with a decrease of about 10 units of output. The p-value measures the probability of observing an effect this large if the true effect were actually zero. Because the p-value in this study is larger than 0.05, we fail to reject the null hypothesis of no effect. The 95% confidence interval provides a range of plausible values for the true effect of maintenance on output. In this model, the interval ranges from approximately negative 22.42 to 1.33. Since 0 lies within this interval, the data do not provide strong evidence that maintenance has a statistically significant impact on production. Finally, diagnostic tests were conducted to evaluate the model assumptions. The residual plot shows that the residuals are centered around 0 with no clear pattern. This suggests that the linear model assumption is appropriate. The QQ plot indicates that residuals are approximately normally distributed. Overall, these diagnostics suggest that the regression assumptions are reasonably satisfied. Thank you for your attention.